Well, first of all, please allow me to thank you for the very kind introduction. And also, I want to thank Mount Royal for the invitation to speak here. It's very interesting because I've been following the course of Under Western Sky since its inception, and I thought, ooh, that's one I want to go to, and it never seemed to work out schedule-wise. And then Rob Boschman sent me an email and said, want to come? And I said, geez, your timing's good on that. I'd love to do that. So I'm very pleased to be here. And as Connie pointed out, I work in 3 areas. Most of my work's in Canada, but I work a lot in the Middle East and also other parts of the world. And in the Canadian context, my work is focused on dispelling the myth of limitless abundance of water. And secondly, I work to translate scientific research outcomes into language the average person can understand and that policymakers can use to craft durable and timely public policy. And finally, I work, and this is where the international work comes in to play, to bring international example to bear on Canadian water and water-related climate issues. And I think in that context in particular, I'm very aware of the Canadian situation, and I hear always at conferences like this much talk about hopelessness when it comes to discussions of climate disruption projections. And I've spent a lot of time thinking about hope and a lot of time discussing with others here and around the world. And I think that despair is the last thing that we need. In fact, I think it's a cop-out, and that's the last thing that we need, and we need to have courage and understanding. We need to be realistic and optimistic, but hope can't be based solely on wishful thinking. And holding back the truth because we're afraid of frightening or offending people, in my mind, often legitimizes the perpetuation of inaction. And I think when I look at Canada in a larger world context, I notice that attention to climate change here is still largely notional. And it's interesting. It's an interesting problem that we'll get to around addressing later. And in my view, I think it's very important to stop candy coating it. Because if we are really serious about sustainability, sooner or later we've got to stop begging people to see what's meaningful about what's happening right in front of their very eyes. And as Meredith Hampstead said this morning, we know what to do, but we have to do it. And why do we have to do it? Well, we have to do it because our planet's changing. Our whole planet, the world is becoming hot and bothered, very hot and bothered. Our collective and cumulative compound effects on every component of the Earth system, including the global hydrologic cycle and the world's climate patterns, are now such that scientists are arguing that we've entered an entirely new geological epoch in the history of the Earth, which they propose to call the Anthropocene. And I think that's interesting that Bruno Latour is coming here, and he will no doubt explain in his keynote all the dimensions that we have presently about that epoch. And this epoch, geologically at least, is marked by the laying down of an entirely new stratum in the geological record, wholly distinguishable from earlier Holocene deposits. And the distinguishing features of the Anthropocene include evidence in the fossil record, as I said last night, of a rise in extinctions at a rate of 100 to 1,000 times faster than in background strata. And many people say to me, well, doesn't every species eventually become extinct? So what's the problem? The reality is that with extinctions in the past, species often didn't die at all, but instead evolved into 2 or more daughter species. And the accelerated extinction rates brought about by human impacts do not allow time for new species to emerge from the old. And the problem here is that our planet's self-regulating Earth system, the system upon which we depend for stable conditions, upon which to base our economy and social stability, is biodiversity-based. And if you take out too many parts, its function will change or cease. And as sociobiologist Edward Wilson has observed, we are on our way to being alone in the world. And the most vulnerable habitats of all, the ones with the highest extinction rate per unit area, include rivers, streams, and lakes in both tropical and temperate regions. And between 1898 and 2006, 57 species of freshwater fish became extinct in North America alone. The Anthropocene stratum is also rich in artificial organic molecules, including polyaromatic hydrocarbons and carbon isotopes from fossil fuel combustion that appear in the atmosphere as well as in marine sediments. And there are so many plastics in this new stratum that some are proposing to call this new epoch the Plasticine. So regardless of what the International Stratigraphy Commission, that's the body that decides on such matters, decrees, there is widespread and convincing evidence everywhere that by way of our numbers and our needs, humanity's effects on Earth system function now rival those of natural systems itself. So when I talk about Earth system, what am I talking about? Well, as I've already hinted, the concept of Earth system function is based on evidence that the conditions that make life possible and tolerable on this planet as we know it today have been brought about and are being maintained by biodiversity. Life in interaction with the physical elements of the planet have over billions of years created a homeostatic co-evolutionary system that functions to ensure optimal conditions for life on Earth, even in the face of periodic shocks. And we have disrupted that homeostasis, making us more vulnerable to those shocks. So given the extent of our impacts, it's not unreasonable to say that as a global society, we face some very substantial and very complex immediate threats to the sustainable presence of the global social order as it exists today. And there was some very interesting comments in the session earlier about this. But within these challenges, I also think that there resides opportunity. And the opportunity in my mind, the opportunity before us, is humanity's big chance to get it right for future generations. And in responding to the urgency and opportunity of finally getting sustainable development right, the United Nations announced its long-anticipated new framework for global action. And while it didn't receive the same attention in the media, the announcement of the UN's 2030 Transforming Our World Global Sustainable Development Agenda last September was, in my mind, at least as important as the later climate negotiations in Paris, if only because this agenda deals with damage we're doing to other elements of the Earth system that are exacerbating and being exacerbated by climate change. So what's important here is that we have at last have a universally understood and accepted definition for what sustainability really means, and a common timetable for implementation of clear goals aimed at achieving measurable targets at both global and national levels. And this agenda, as many of you will know, is constructed around 5 themes: people, planet, prosperity, peace, and partnership. It's also important to note that it applies equally to the developed world as it does to the developing world. It makes it clear that unless we all take common goals at the national level seriously and implement measurable actions at the national level at every country in the world now, we cannot achieve sustainability globally. So this means there can be no laggards, particularly in the developed world, and it also means the world cannot afford to leave anyone else behind. In my view, this is the largest human endeavor ever undertaken in the common interests of humanity. And I think it's critically important to note that the establishing these goals, in my mind, may in fact be the most important thing humanity has done for its own future since it created the UN. And if we want to make true sustainability possible, this is the total agenda that we have to translate down and make meaningful at the national, subnational, regional, and community level. So, how does water fit into this? Well, of the 9 critical Earth system boundaries which we dare not cross, water plays a significant role in 7. There are 17 goals in the 2030 Transforming Our World agenda. While it's important in its own right, water plays a role in 13 of the other 16 goals, including ending poverty and hunger, creating healthy lives, gender equity, energy security, promoting economic growth, resilient infrastructure, sustainable cities and economies, and taking action on climate change. Goal 6, however, pertains specifically to water. The global goal with respect to water is to achieve universal and equitable access to safe and affordable water and sanitation for all. The goal also aims to improve water quality by reducing pollution, halving the proportion of untreated wastewater, and substantially increasing recycling and safe reuse globally. The 2030 Transforming Our World agenda makes it clear, however, that sustainable development can no longer aim for environmentally neutral solutions. If we are to achieve any meaningful level of sustainable development, all development has to not only be sustainable, but restorative. We can no longer simply aim to slow or stop damage to the Earth system. We have to thoughtfully restore declining Earth system function. In order to achieve this end, it's important to incentivize acceleration of already advancing reform in both the engineering and planning professions. We need to see a different world and work toward that world. We face so many overlapping and intersecting crises, we can no longer afford to fix them one at a time or in isolation of one another. All future development must seek double, triple, if not quadruple benefits in terms of restoration of fundamental Earth system function as reflected in biodiversity stability, efficient water use, soil vitality, carbon storage, and human and planetary health. And nowhere is this more true in my mind than in agriculture. What we need is another agricultural revolution, one focused this time on agricultural practices that increase productivity and production while at the same time help maintain ecosystems, strengthen capacity for adaptation to climate change, and reduce the impacts of extreme weather, drought, flooding, and other disasters that progressively diminish land and soil health. And the thing that's important about this, we need to do this by 2030. Regrettably, the fact is emerging that many of the sustainable development goals in the Transforming Our World agenda cannot be met unless we address climate disruption and its impacts first. Climate impacts have begun to affect development trajectories in all nations, rich and poor. And the link between recurring extreme weather events and challenges of maintaining critical physical and social infrastructure in developing countries has already been noted by organizations like the UN and the World Bank. The extent to which climate disruption has begun not just to slow, but to reverse economic development has also been recognized as a global economic threat. So in January of this year, the World Economic Forum held in Davos released its annual Global Risks Report. And I know many of you have seen this and probably responded to it. And as part of that survey, nearly 750 experts assessed 29 separate global risks for both impact and likelihood over a 10-year time horizon. And the risk with the greatest potential impact in 2016 was found to be the failure of climate change mitigation and adaptation. And a haunting image of the extent and nature of contemporary risks was put forward also at that economic forum by the global insurance giant Munich Re. The image was a map of interconnections between various economic, environmental, geopolitical, societal, and technological risks associated with the failure to effectively and meaningfully adapt to climate change. And what this map illustrates is the cascading effect of the failure to properly and quickly adapt to hydroclimatic change. And on a global scale, failure leads first to greater vulnerability to extreme weather events, to food crises, water crises, large-scale involuntary migration, and further man-made environmental catastrophes, which in turn lead to biodiversity loss and Earth system collapse. Now, what's interesting here is that this isn't speculation. This is already happening. The terrible violence in Syria and the spillover effects in Europe in 2015, I should point out, did not start as a war. It started as 5 years of drought that contributed to sparking a war. As ISIS is demonstrating, targeting and using water resources as a weapon can cripple food supply, destroy local economies, and disrupt water security and climate stability. So we can see how these impacts can spill out of the countries in which there are conflicts to affect whole regions, and that's exactly what we've seen. So we're confronted with new realizations of the critical importance of a relatively stable hydrologic cycle. What we haven't understood to now is the extent to which fundamental stability of our political structures and global economy are predicated on relative hydrologic predictability. And as a result of the loss of relative hydrologic stability, political stability and the stability of our global economy in a number of regions in the world are now at risk. And we're only beginning to understand how truly complex this has become. So what assessments like this reveal is that water security, food security, and climate stability are inseparable. One is implicit in the other. It could even be said that they're the same thing. Water, food, and climate security are critical elements of sustainability. Without stable water and climate regimes, sustainability will forever remain a moving target. So we need to define a safe place in terms of sustainability to which all of humanity must aim. And in this quest, knowledge is not enough. We need the will and the permission of the peoples around the world to solve global change problems. And that's why COP21 in Paris was so important. We need the will and the permission because as the motivating theme of COP21 made it clear, later it will be too late. So, how did we do in Paris? Well, perhaps it was the British journalist George Monbiot who said it best. By comparison to what it could have been, what happened in Paris was a miracle. Compared to what it should have been, it was a disaster. Now, the reason for that is that temperatures on Earth rise 4 degrees to 5 degrees Celsius. Significant areas of the planet are likely to become uninhabitable for at least part of the year. We're actually starting to see that sort of phenomenon now. In the 5 years, the parties to the convention have granted themselves to establish how much they will contribute to global emissions reductions. We could very well blast past any real opportunity to limit warming to 1.5 degrees Celsius. And the delay in action could actually put 2 degrees Celsius out of reach also. So cut the numbers any way you want, but at the end of the Paris conference, we have only less than 50% chance of avoiding runaway climate impacts. So what's the big deal? Well, it falls out that the difference between 2 degrees Celsius of warming and anything warmer is the difference between an unpleasant world and a potentially uninhabitable one. And time matters. 2030 matters because if we wait until 2100 to act, it could take 100,000 years to once again stabilize in any meaningful way what the climate is doing on this planet. The agreement also has other shortcomings. There's no mention of direct human health risks, nor is it clear where the money is going to come from to finance even what is proposed in terms of climate action now. The agreement relies on transparent, non-adversarial, non-punitive compliance. It's also an agreement that's easy to get out of. And because it's not binding, the agreement is also highly vulnerable to political manipulation. The question then becomes whether it can survive political turmoil or the election of radically new and different governments. How, for example, would the agreement fare if Donald Trump is elected President of the United States on November 8th? The biggest failing of the Paris Agreement, however, may reside in the fact that it only offers a long list of urgings, invitations, and encouragements to signatories to act now and in the future. There's nothing to force the signatories to do so. But there is hope. The real miracle in Paris is that for a moment at least, we got 193 nations, rich and poor, to agree to something, however limited, at the same time. We don't do that very often. And that is an achievement in itself. This is a beginning, not an end. And the first thing that's really important about the Paris Agreement is that it nests climate change within the larger context of the 2030 Transforming Our World agenda, as well as other important UN conventions. The agreement makes it very clear the effort must be to hold the increase of global temperature below 2 degrees and, if possible, below 1.5 degrees. It recognizes also the need for effective and progressive response to the climate threat on the basis of the best available scientific evidence. In establishing the 1.5 degree target, the agreement recognizes the specific needs and the special circumstances of developing countries and countries particularly vulnerable to harmful climate effects, obviously. The agreement also conversely recognizes that many nations and regions may be affected not only by climate change, but also by the impacts of measures taken to respond to it. So when you look at an example of a place like Alberta, what could happen to places, you might ask, that rely heavily on oil and gas if they don't restructure their economies around new realities? And in a sense, you begin to see that relying on oil and gas to drive your economy is like holding a whole bunch of aces in your hand and then discovering that the aces don't count anymore or count for less. So the Paris Agreement, however, faces formidable obstacles, not the least of which are national and regional economies. The first test of the durability of the Paris Agreement will be to see if the parties to the agreement actually ramp up their carbon reduction programs between now and 2020. And the second test will be to see if the $100 billion climate fund is topped up in the next 4 years. And then the final test is whether or not we'll be able to keep our Paris promises and build on them. And I should point out that we examined very carefully the provincial promises compared to what Canada nationally promised in Paris. And at the very best scenario, we're likely, with current policies, maybe reach 58% of that goal. We have a long way to go. The Paris Climate Conference, the French ambassador to Canada, Nicolas Chapuis, said in Ottawa 3 weeks before the conference began, is an opportunity to put out the fire that's burning our house down. Now, I think after that conference, flames may no longer be seen shooting out of the roof as they were when the conference started. But we have to recognize it's not just our house on fire. The world is going to get a lot hotter and a lot more bothered before things get better. And I should say crowded, too. It appears that we have been laboring under an unfortunate misconception with respect to the number of people to whom we will need to supply water and sanitation, feed, clothe, employ, and provide health care, as well as peace and security for in the future. Over the past decade, it's been generally held that perhaps miraculously, the world population was somehow going to level off and stabilize around 9 billion. And that's where the goalposts for sustainable development were largely set. And as this seems to be the case with most parameters by which we measure sustainability of human presence on the planet, these goalposts have moved again. And the 2014 biennial report on population projected that we should expect to live in a world we will share with between 9.6 and 12.3 billion people by the end of this century. And public health officials around the world are genuinely hot and bothered because climate change is increasing the vulnerability of humans and the domestic plants and livestock upon which we depend. And they're becoming more vulnerable to disease threats. And the fact is we have no idea what a warmer mean global temperatures will awaken. And it's very interesting that epidemiologists explain that many kinds of bacteria, many of which we've yet to identify, obey a scientific principle first proposed in 1934 by the pioneering ecologist Lorenz Bass-Becking. And this is what he said: everything is everywhere, but the environment selects what becomes active. What Becking meant was a large fraction of genetic forms occur around the globe. Most of these forms, however, lie dormant. Together, however, these forms are in essence a seed bank within which each species begins to multiply when the environment changes in ways that suit its DNA preferences. So with bacteria, these sleeping cells will awaken when presented with the right acidity, the right nutrients, and the right temperatures. And what global health experts are telling us, that a vast storehouse of ancient bacterial DNA exists ready to leap into new bacterial forms with the slightest change in Earth system conditions. And we have no idea whatsoever what new bacteria and viral agents might come into instant existence as a result of the warming of the world and the changing of Earth system conditions that we're bringing about. And these latently active species are all around us, too small even to be seen by most microscopes. So as we advance toward altered Earth system conditions, we'll be seeing life forms that we've never experienced before, many of which we will fear. And we know what they look like. Ebola, H1N1, and Zika virus are just a hint of what will awaken in terms of pathogens in the future as we continue to modify the conditions of life on Earth. So we have to be ready for anything. Now, population is a major issue, And I know we're talking here about water, and I think it's important as a vehicle to discuss these other issues. I think, while population is important, in my view, the bigger problem is the cumulative and compound effect of human numbers and activities on the complete Earth system function. And because what we're doing here is, in addition to altering our planet's global nutrient cycles, we're causing changes in the chemistry, salinity, and temperature of our oceans and the composition of our atmosphere. And Michigan, when you were talking this morning about these tipping points, I was going, one that really bothers me at night is ocean acidification. That's the one. But we're also changing the global water cycle, and we're changing precipitation patterns as a result. And if this is of interest to you, I urge you to hear Dr. John Pomeroy's keynote this afternoon. He is truly expert in explaining many of these phenomena. So let's look closely at how these cumulative and compounding human effects are making sustainability a moving target here where we live in Canada. So here are some of the effects that we need to stabilize if we don't want adaptation and resilience to constantly beyond our reach. Even before climate became an issue, we'd already begun altering the global hydrologic cycle through rapid and expansive alteration of land use and cover. And more than half of the entire surface of the planet has been significantly altered by human activities. And such changes interrupt the stability of the hydrometeorological cycle as we've known it, making events that allow larger cities to become more susceptible, of course, to flooding. And these same effects are also making cities more vulnerable to drought and heat. Land use changes, however, are only the beginning of the effects that we're having on the global hydrologic cycle. And I think it's fair to say, and all of you will know this, that reality is saturated with water, and life is made possible by all the ways in which water reacts with nearly every element in the physical world. So you change a few parameters that pertain to water, and the world you see out your window becomes different. But some parameters have more influence than others over the nature and function of any given hydroclimatic circumstance. So the changing of a single defining parameter, temperature, for example, changes all of the other biogeochemical parameters. And if our temperature changes, an entire new geometry is created around that change. And the most frightening discovery of this young century is that this is exactly what's happening. The rate and manner in which water moves through the global hydrologic cycle is accelerating. It's happening right before our very eyes, here and everywhere. And it's been very difficult, even for experts, to fully grasp the extent of what the loss of relative hydrological stability means. And just think about this, some 52 million cubic kilometers of water are being cyclically redistributed at any given moment through the global hydrologic cycle. And what we've discovered is that 10 trillion metric tons of water are shifted from one hemisphere to the other in the form of winter snow cover during only one annual cycle. And the volume and weight of water moving continuously around the surface of the Earth and between the surface and the atmosphere annually is that it's so great that it actually deforms the shape of our planet's surface. And redistribution of the weight of water over the Earth's surface actually causes changes in the spin rate of the planet, which affects the behavior of all of the planet's fluid systems, including both the hydrosphere and the atmosphere. And what we're also discovering is the ratio of snow to liquid water in the great seasonal redistribution of precipitation in the northern hemisphere is changing with huge potential consequence for all of us. And nowhere is this more evident right here in the Rocky Mountains. Research conducted by the Western Canadian Cryospheric Network has demonstrated that we lost some 300 glaciers in the Mountain National Parks region of the Rockies, Canadian Rockies alone, between 1920 and 2005. And the loss is expected to continue with over 90% of the ice that exists in the interior ranges of Canada's western mountains expected to be gone by the end of the century. And this matters in that it confirms that the hydrology of the entire Canadian West is changing, and it's changing fast. And it should be noted that the loss of glacial ice is only a symptom of a much, much more serious problem. The same warming that is causing our glaciers to disappear so quickly is reducing snowpack and the duration and extent of snow cover throughout the entire Mountain West. And snowpack and snow cover are now declining by 17% per decade. And by mid-century, it appears that the Canadian West will be as much changed by this as it was by European settlement. So what we're seeing in Canada also is that the loss of the Arctic sea ice and the rapid reduction in the extent and duration of snow cover in the Northern Hemisphere are reducing the temperature gradient between the poles and the tropics. And it's this difference in temperature between the polar region and the warmer air to the south that largely defines the behavior of the jet stream. And the less ice there is in the Arctic, the slower and wavier the jet stream becomes and the more erratically it behaves. And we see from the altered behavior of the jet stream that warmer atmospheric temperatures do not automatically translate into warmer weather. In a uniformly warmer and therefore more turbulent atmosphere, both warm and cold fronts end up and persist in places in the mid-latitudes in which they were not common in the past. And that's why, in combination with the atmosphere's capacity to hold more water vapor, both summer rains and winter snowstorms are persisting longer and causing greater and greater damage. So I just want to point out that since we stayed in a casino last night, that from this you can see that the Arctic is not like Las Vegas. What happens in the Arctic does not stay in the Arctic. It's a much bigger problem than we thought. So it's important to understand that it will not just be the presence of water that will be at issue as hydrometeorological conditions change, but its absence. And this is there's a direct climatic connection between water and its diametric and symbolic opposite, fire. If you don't have one, then you often get the other. So higher mean annual temperatures, especially in northern Canada, will result in an increased wildfire risk. A slower and wavier jet stream will cause the conditions that exacerbate the wildfire threat to intensify and persist longer in vulnerable places. So, employing two contemporary climate change modeling suites, Mike Flanagan and his colleagues at Natural Resources Canada and now at the University of Alberta were able to predict the impacts increased carbon dioxide concentrations will have on the length of the fire season in Canada's boreal forest. And 10 years ago, that research projected that the fire season would increase from 10 to 50 days over much of the Canadian boreal. And as the fire season will be extended, in some places by a month and a half, it's logical to expect an increase in the total number of fires burning during that season. So with a hotter, higher energy atmosphere, we should also expect a greater area of our forests to burn each year also. And what we see from this, scientists predicting a whopping 75 to 120% increase in the amount of area burned each year by the end of the century. So we knew 10 years ago that Canada was going to be faced with huge ecological, economic, and social impacts associated with the rapid and disproportionate rise in temperatures in the northern boreal. And unfortunately, no Hollywood disaster movie could come close to depicting what happened in and around Fort McMurray. And at $9 billion, and it's probably still counting, the fires in northern Alberta rank as the most costly natural disaster in the history of this country. Now, what's interesting about this is that the link between extreme weather conditions and the growing number of climate-related natural disasters everywhere is getting really hard to ignore. And while it has been conventional wisdom among scientists for decades that no single event could be attributed specifically to climate change, the latest research indicates that that may no longer be the case. A major report published by the prestigious U.S. National Academies of Science in March of this year clearly states that science has advanced to the point where, in certain instances, anthropogenic attribution may be possible. So the principal reason we're incapable of being able to accurately attribute any of extreme weather events to anthropogenic causes is not because they're not real. It's because our models are still in development, or we have limited long-term data. And it's also true that in many cases we don't even know enough about some forms of extreme weather events, like tornadoes, to make reliable judgments on how much human influence can influence their intensity and duration. Now, that said, the science behind attribution of extreme weather events to anthropogenic influence has advanced a great deal in recent years and continues to evolve. And by extending the historical observation record, improving remote sensing, and employing multiple models on studies on specific aspects of weather and climate extremes, we're constantly improving our ability to accurately attribute the impact of human presence on and activity on extreme weather events. So if we want to have hope for the future, there's no better time to talk about climate disruption now, when we can see exactly what inaction might continue to cost us, not just economically, but in terms of human duress and suffering in the future. The most profound changes to the hydrologic cycle relate to how much more water the atmosphere can hold. And we've known for more than a century that for every degree Celsius of warming, we can expect the atmosphere to carry 7% more water vapor. And if you increase the temperature of the atmosphere by 2 degrees, well, it can carry as much as 14% more water vapor. And if you raise the temperature by 4 degrees, it will carry 28% more water vapor. And you can see that this is nonlinear because you're always adding to a higher number. And what this does is it changes everything. It's important to note that the amount of water vapor in the atmosphere can carry increases in this nonlinear way. And that's why recently discovered phenomena like atmospheric rivers demand our full attention. We're witnessing things we haven't either seen or weren't able to recognize before. And these include these atmospheric rivers. These atmospheric rivers likely existed for an eternity, but only now, as a result of satellite remote sensing capacity, do we know of their existence and their dynamics. These corridors of intense winds and moist air can be 400 to 500 kilometers across and thousands of kilometers long, and they carry the equivalent of 10 times the daily discharge of the St. Lawrence River. And these huge rivers of water vapor aloft are carrying more water and causing flooding of magnitudes that we've never witnessed before. And we've recently discovered that atmospheric rivers, like the winds of the jet stream, also derive their energy from differences in temperatures between the poles and the tropics. And it, of course, relates to the Clausius-Clapeyron relation in that the warmer the air, the more water an atmospheric river can carry. And the disturbing lesson from this is that we have to stabilize the composition of the Earth's atmosphere, or sustainability will remain out of reach. So unlike earlier epochs in the Earth's history, which were brought about by meteorite strikes and other geological events, the impacts that we have right now are marked by overall consequences of our activities on the Earth system. And Kathleen Dean Moore is going to speak here. And you've got to read her book. I mean, she's just amazing. And what she said, she pointed out, dinosaurs didn't have a chance, but we do. And they didn't have a choice, but we do too. So I know that some of you may feel that it's a dark view of what's happening in hydroclimatic change, but I think it's important to recognize what's really happening here. This September marks the 379th consecutive month in which global temperatures were above the 20th century average. And the ocean-driven evaporation precipitation cycle, which largely defines the global climate, accelerated by 4% between 1950 and 2000. And because we say that our best areas, what we say are our best efforts are not enough, the Earth system changes appear to be accelerating. And perhaps you've noticed this. With respect to hydroclimatic change, 2030 is the new 2050, and 2050 is the new 2100. So things are moving. And we now realize that the Earth system can no longer supply resources and absorb wastes without the threat of abrupt and irreversible changes of state. And abrupt changes appear to be occurring. And this is why I think there's a greater urgency than we're talking about right now, certainly in Canada. And for 40 years, climate scientists have been telling us that there are going to be surprises as the trajectory of climate effects unfolds. And these surprises keep presenting themselves. Here's the latest one. On Monday, August 15th, of this year, NASA released its global temperature data for July and announced that a stunning record had been broken. It was not just that July was the hottest month on record, or that it was the hottest month on record for the 15th month in a row. July 2016 was the hottest month for as long as humanity has kept records. Proxy data, in fact, suggested that July of 2016 likely marked the warmest absolute temperatures since human civilization began. So depending upon how you count temperatures, and there are a number of ways to do that, July of 2016 already surpassed the 1.5 degrees Celsius mark above pre-industrial levels the Paris Climate Agreement sought to limit warming on this planet in the future. Warming, in fact, may have touched 2 degrees Celsius during the February-March heat wave that coincided with the peak of this year's El Nino. Now, again, this is important because 2 degrees is the point at which most scientists agree that dangerous climate impacts become unavoidable. And the really unfortunate timing in this is that the UN report on how the world might keep global temperatures from rising beyond 1.5 degrees Celsius isn't scheduled to be released until 2018. So addressing climate change requires urgent and persistent ongoing policy attention. And what we're seeing now is the kind of attention addressing these issues demands keeps assuming new shapes. And you were talking about this morning. The urgency is different than we originally thought. In July of this year, or of 2016, one of the editors of EOS, the official scientific journal of the American Geophysical Union, published a blog that introduced new perspectives on climate tipping points. And the key message Michael Ellison wanted to convey was that if science is to aid policymakers in service of real progress on addressing the climate threat, we must all start meaning the same thing when we use the same words to describe climate impacts. And Ellison noted that many of the current and future effects of climate changes have been described in both popular and scientific literature as tipping points, a term usually associated with the triggering of abrupt consequences. And citing recent research on tipping points, Ellison noted that the characterization by popular writers like Malcolm Gladwell of tipping points as abrupt notwithstanding, the tipping point in the melt of something as large as an ice sheet or changes in ocean circulation might take decades or even centuries to unfold. But then he said the real thing that mattered. He noted that despite our current concern about tipping points in climate systems, we are currently ignoring how non-tipping points in climate and other parts of the Earth system might cause truly abrupt tipping points in our social and political systems. So what's becoming increasingly apparent is that abrupt social and economic tipping points may be just as or even more important than slower moving critical hydroclimatic thresholds. And abrupt social tipping points triggered by floods and droughts, for example, can have immediate consequences on all manner of issues from public health to the stability of political regimes. So where's water taking us? Well, right back to you and to this conference. Here we are again, already over thresholds we never imagined existed or that we would ever cross. And what this means is that we can no longer count on self-willed, self-regulating natural landscapes to absorb human impacts on Earth system function. Whether we like it or not, we have to assume responsibility for staying within Earth system boundaries. So if sustainability is to remain in our grasp, we need a new guiding narrative. As the writer William Kittredge once said about the American West, what we need most urgently is a fresh dream of who we are, one that tells us how to act, new stories about taking care of what we have that drive us to take appropriate action. What we need to do is to articulate a new narrative. And what we're engaged in is nothing less than a struggle to redefine our dominant mythology. And given our circumstances, finding that story should be our society's most urgent common enterprise. There's no one here who doesn't understand the issues. Hydrometeorologic regimes are changing. Invasive species have arrived. Lake temperatures in Canada are rising at twice the already accelerating global rate. Algal blooms in places like Lake Winnipeg and elsewhere are getting larger and persisting longer. These undesirable conditions are spreading to water bodies throughout the continent. Scientific evidence demonstrates that these problems are getting worse and could easily get away with it on us if we're not managed well. So one of the most important things I think we need to be able to say is that these are not just environmental problems. These are problems that could have significant social and economic consequences. And one of the most difficult things we find with this is that these problems are jurisdictionally complicated. And the problems associated with hydroclimatic change are now too complicated and accelerating too quickly to be addressed by any one given level of government. The problems also involve several ecological as well as social and economic tipping points that could result in irreversible changes in the nature and character of the Canadian West by mid-century. And the problems we face do not have to reach what scientists officially declare as ecological tipping points to trigger tipping points in the way we live, with undermining the prosperity of the Canadian West with huge consequences for anybody who lives here. So fortunately, we have the will to solve these problems. We don't need to start over again here, and it would be wrong to do so. Willingness exists at all levels of government, starting with municipal mayors and reeves, extending right upward into the administrations of both provincial and federal governments. And there's big commitment, as you see at conferences like this, from NGOs and the research community. And in many places, we have solid organizing principles, as we saw this morning, and plans that will allow all interests to work effectively together. And we have urgency. Now, from a United Nations perspective, what is so different from many other places in the world is that we can actualize this plan simply by effectively mobilizing and linking the commitments that have already been made and energizing and expanding them. But we have to get out of our silos to do that. What's missing right now is an organizing agent, a recognized, adequately resourced, high-level interest of people charged with unifying all interests in each region nationally with the goal of stimulated, coordinated, ongoing action. So I speak now to the students who are here today. We need you to become that organizing, motivating, and inspiring agent. And I'm sure that none of us today need to be reminded that there's something far greater at stake here than simply adapting somehow to hydroclimatic change. What's at stake here is the future. The ultimate goal to which we are aiming together, locally, is to preserve our prosperity and a sense of place that we have while making the West a place where people want to live, not leave, in a warming world. And I know what some of you are probably thinking, well, what can I do? I'm just one person. And I think Kathleen Dean Moore will tell you the same thing. First of all, stop being one person. Look around you. You're clearly not alone. Trust what you know. Trust who you know. And build that network from here. And as Mark Twain once famously said, do the right thing. It will gratify some people and utterly astonish the rest. And as Kathleen Dean Moore advises, think like a river. In rivers, no one flow pattern persists indefinitely, nor does the river stay the same. When, after much deposition of sediments, there are so many obstacles and islands in a channel that it can no longer carry all of its water and sediment. And at that point, the river crosses a stability threshold and the current carves in a new direction. It's in a process called avulsion. Rivers can change their course suddenly and dramatically. And that's what we need our society to do now. If we work together, our small influences on the flow of the river of time can cause huge and sudden changes. What we're witnessing is what warming does to water and weather and how life is impacted in response. So whether in rivers or lakes, in the global ocean, or circulating in the atmosphere, pay attention to the warming of the world's waters, for it'll be through water that climate change will express itself most fully. Follow the water. It will show us who we need to be and what we need to do to create the West we want. Thank you very much.